Yeah. Hello, everybody. Hello, hello. Hi. Am I audible? Am I audible to you? Okay. Okay. 24 people have joined. We'll wait for 2 more minutes. Okay. And today, during the lecture, you might face some disturbances, some dole noises coming from the background because there are elections going on here locally. And there are small kids of 10 to 12 years running around with dole and shouting BJP Jindabad, Congress Jindabad. Okay. So you might hear those sounds a little bit. Okay. So please bear with me. Okay. 24 people have already joined. So, did you guys use your weekend wisely? Did you guys solve the? I'm from Rajasthan, Ashish. I'm from. So, have you guys heard of Udaipur? Yes. So, I'm from Udaipur, Rajasthan, and there are these Nagar Parishad elections going on. So, the elections are on 28. So, the promotion and everything is on peak right now. So that's why you might hear some voices. There were people running around just a few minutes back. That was what I was checking. Okay. So did you guys use your weekends wisely? Oh, Vishal, you're from Udaipur as well. Cool. No, not the case, Milind. Not just foreigners know about this place. It's a very good place. If you haven't visited, you should visit there once. At least once in your lifetime, you should visit and try visiting during the monsoons. Cool, Vishal. Probably we can catch up. Okay. So coming back to the point, did you guys utilize your weekend? Did you guys solve the backlogs? Any one of you? Okay, cool. Because that's the time you guys will be getting mostly to cover your backlogs. Okay, so it's 9:05 already. I'll start with today's lecture. Okay, so in the last lecture we looked about the basic principles of hashing. How do we use hashing? And won't we be having any other class this week? I think we will be having. I can check the schedule. Just 1 second. Let me check the schedule. I'm not aware about the schedule. I think this one. Is it not visible to you guys in the dashboard whether you have classes scheduled or not? Okay, so it's updated only till hashing 2. It's updated only till 25th of January. Probably you will be having classes this week. It will be updated. Okay. And reward system like to whom I can contact in panel. I was not able to give the contest. Okay, Milind. Can you send me your email, Milind? Can you send me your email personally? Your email and the date of the contest. I'll raise the issue immediately, and I'll have a look at it. I'll raise the issue with the development team right away. And when was the contest, Milind? Okay, Saturday. Okay, okay. Can you then extend contest time till Monday end of the day? If we so that if we have one weekend and weekday as well. Yeah, okay. So that is not in my hand, but I can definitely raise your concerns. I can discuss this with Tarun or Kshitij. Okay, so your issue was you started at 5:55 a.m. and you had only 5 minutes on the clock. Cool. 6. I haven't seen any of the contest ending time displayed as well. I was able to see. Okay. Contest end time was not getting displayed. Okay, so maybe we can start discussing these issues at the end of the class also. Let's start with the class. It's already 9:08. Okay, otherwise we'll get delayed. Okay, so in the last class we discussed about hashing and we discussed a few problems from hashing. So how we use hashing using a map or a hash set. Okay, so let's start with a very basic question. Okay, so let's start with a question. Okay, so what's given to you is you're given a string S. Okay, and the string, let's say, is BBA, ABB. Okay, and what you need to see is, can S be rearranged? Okay, can the string be rearranged so that it appears as a repetition of k similar strings? Okay, so let's say in this case, if we were given the value of k equal to 2, can we write this as BBA, BBA if we rearrange this string? And can we see that it can be written as a repetition of two similar strings? Is the question clear to everyone? Okay. Let's start with the solution. It's a very simple problem. Okay, you won't go ahead with root throws and this and that. Can anyone tell me how we can solve this problem? Can anyone tell me how we can solve this problem? Correct, Ankit, your solution is correct. Please try the thing, guys. Correct, Rajkiran. Correct. Second string. Okay. Correct. So most of you are given the correct solutions. Okay. So let's say we are given any arbitrary value k. Okay. So can I say that that string S, okay, if we have to write it as a representation of k similar strings, okay, so can I say that this means that we have k buckets given to us, okay, and in each bucket, okay, we need to have similar characters. That is, all the characters in the bucket should be same. Can I say this? Correct. I can say this. So can I say that, let's say any element X, okay, will be a part of all the buckets, will be a part of all the k buckets, right? And that X element will be coming in each bucket the same number of times, let's say some n times, correct? So what will be the frequency of X in this case? The frequency of X will be kn, correct? So can I say that for this particular string to be written as k similar strings or a combination of k similar strings, can I say that the frequency of each element, okay, frequency of each element mod k should be equal to 0? Is this clear to anyone have any doubt in this question? Frequency of all elements should be divisible by k. Okay. Now just one thing. Okay. Can we avoid checking for this also in some cases? Can we avoid checking for each element in some cases? Can you think? Can we eliminate any subs? Can we eliminate any string? Okay. Can we eliminate any string by just one comparison? Can we try to eliminate? Okay. That will not be possible in each case, but can we at least try to set a base case where we can eliminate some cases in just one comparison? Correct. I'll explain this, Milan. Correct. Some of you have given the correct answer. Okay. So can I say that if the frequency of each element is divisible by k, overall the size of the string will also be divisible by k? Can I say this? Yes. So before starting to check for all the elements, can we check if the size of that element itself, if the size of that string itself is not divisible by k, we cannot ever divide that into k similar buckets or k similar strings. Okay. And if that is divisible, then we have to check for the frequency of each element. And how will we check for the frequency of each element? We can, if we are given only small or large, we can do it either using both the methods. We can do it using map or we can do it using array. Okay, you can do it using both the cases. Okay, cool. So this was just a basic problem. Okay, now today's main focus will be on geometrical problems. Okay, so what is geometrical problems? You'll be given a 2D plane and you'll be given some points in that particular plane and you'll be asked about some questions from that plane. Okay, we'll start with the brute force approach for all the questions, and then we'll eventually see how we can use hashing, okay, to improve the time complexity or decrease the space complexity in each case. Okay, so let's start with the first question. Okay, you're given n points in a 2D plane. Okay, you're given n points in a 2D plane. Okay, and what you need to do is you need to find maximum. Let me just first add a bookmark here. Sorry. We're given n points in a 2D plane, and you need to find maximum number of collinear points. Okay, that is, you need to find maximum number of points that can lie on a given on a line. Okay, so let's say you're given this 2D plane. Okay, and 1, 2, 3, 4, 5, 1, 2, you have 1 comma 1, you have 2 comma 2, you have 3 comma 3, you have 5 comma 5, you have 4 comma 1. Okay, so this is 1 comma 1, this is 2 comma 1, this is 2 comma 2, this is 3 comma 3, this is 5 comma 5, this is 4 comma 1. Let's say we have another point here, 5 comma 3. Okay, so in this case, should they lie on the same line or they can lie on a different line? Yes, you need to find the maximum number of collinear points. That is the maximum number of points that can lie on one line. Okay, so you have to find the maximum of that. So let's say so how many lines can we draw in this? There can be this one line. There can be this one line. Okay, there can be this one line. Okay, so we need to find the maximum number of points that can come on one line. Okay, so in this case that will be 4. Is the question clear to everyone now? Milind, is the question clear to you now? Okay. Okay, cool. Okay, now let's start. Okay, now let's start solving the problem. Okay, so for a line, what is the very basic statement that you can say? Correct. Some of you are already giving a solution. And then same line. X1 minus Y1 will be same for all points in the same line. Mod X1 minus Y. How will it be same for all the points on a given line in the same line? Ashish, can you explain? How will it be same? It's not correct what you are saying. Yes, no, your solution is correct. Okay. So now let's start with the solution for this. Okay. So how can you represent a line in a 2D plane? That will be just in this case, right? That will be just in this case. Otherwise, your answer won't be correct, right? So slope will be same from all points of the origin. No slope won't be same from all points of the. So let's consider this line. Okay, let's consider this line. Okay, in this line, the slope from origin for point 4 comma 1 will be this. The slope from origin for 4 comma 1 will be this, and the slope from origin for 5 comma c will be this. So are these two slopes same? Chirag, is this clear? Slope from origin, slope will be same for all the points from the origin. No, that is not the case. Shashi, your solution is correct. Okay. So how can we represent a line in a 2D plane? We can represent a line in a 2D plane in the form of an equation. Okay. In a linear equation in two variables, x and y. Okay. And there are three ways in which we can represent that. First is y equal to mx plus c. Okay. Where what is m? M is the slope. Okay. And what is C in this case, guys? What is C in this case? Correct. Correct. So C is the intercept. Okay. So C is the value when x is equal to 0. Okay. So C is the value of y when x equal to 0. Correct. That is y intercept. Okay. The other equation is we can write an equation of a line using any 2 points on that given line by y2 minus y1 equal to m x2 minus x1. Okay, and the third way to write a line is ax plus by plus c equal to 0. So ax plus by plus c equal to 0. Okay, all of you are familiar with these three equations, right? Okay, okay, cool. Now, some of you have said that we can use the slope to represent the line. Okay. Let's not directly get there. Okay. So let's start discussing the solutions first. Okay. So the first approach will be a brute force approach. Okay. What will be a brute force approach? Okay. How many minimum number of points are required to create a line? How many minimum number of points are required to create a line? Correct. Correct. There are 2 points required to create a line. correct? So what will be the brute force approach to solve this problem? What will be the brute force approach to solve this problem? Correct, Vishal? Correct, Chirag? Just try to think. Just try to think how we can solve this. Correct, correct. Okay, so how can we do that? How can we do that? Okay, can we find the slope of the line? Let's say not slope. Slope will not be the. Okay, so can we find the equation of the line using any 2 points? Can we find the equation of the line using any 2 points? Right? We can find the equation of line using any 2 points. So for all x and for all y, for all points, okay, not x, y, let's say for all p1 and p2, for all p1, for all p2, okay, we'll find the equation of the lines, okay. We found the equation of lines. Now can we say that if we check for all the elements and if we put the value of x and y in these equations, we'll get our answer as 0? Yes, Milind, you can do that, but that will increase the calculation. Yes, you can do that, not an issue. Okay. So what will be the time complexity in this case? What will be the time complexity in this case? Correct. Order of n cube. Okay. Why order of no, Rajkiran, not correct. Chirag, not correct. Why order of n cube? For all p1, for all p2. Okay. This is already order of n square. Okay, and inside that we again check for all points whether they lie on that line or not, because we need to find the maximum number of points that lie on any particular line. Okay, so we need to check for all the points again. Is this clear? Is this clear how it is order of n cube? Okay, any doubts in this? Any doubts in the brute force approach? No. Okay. Okay, now, okay, now let's try to optimize this. Okay, let's try to optimize the brute force solution. Okay, so can anyone tell me, using any of these three equations, instead of using the points, okay, instead of using the points, can anyone tell me any other way in which we can specify or we can uniquely distinguish a line, or we can uniquely define a line? Correct, Vishal? So instead of using, so one way to define a line is any 2 points that lie on that line. Okay. One way to define is any 2 points that lie on the line. Correct. Is there any other way we can use to define a line? Correct. Correct. Amit, correct. Utkarsh, correct. First and the last point of the line, no. First and the last point of not. The lines are always infinite. Okay, there's no stop to a line. Correct, correct. Okay, so most of you have guessed it right. Okay, so from equation 1, can we see that for each line we will have one equation? Okay, that is a pair of M and C. Can I say that? Can I say that each line can be uniquely represented as a pair of M and C, that is the slope and the intercept? Okay. Anyone has any doubt in this statement that I've said? No, right? Okay. So since we can use the slope, okay, m, and we can use the intercept to represent any line, okay. And how can we calculate the slope? How can we calculate the slope? If we use the second equation, and we use any 2 points, what will be the value of slope? The value of slope will be x2 minus, the value of slope will be y2 minus y1 upon x2 minus x1. Is this clear? Okay. What will the, how can you calculate the value of c now in terms of x1 and x2 and y1 and y2? Can we use equation 1 to calculate the value of c in terms of x1, x2, y1 and y2? How? Correct, Milind? So the equation was y equal to mx plus c. Okay, so for x and y, you can use any one of the points. You can either use x1, y1, or you can use x2, y2. Doesn't matter, you'll get the same answer. I'll be using x1 and y1. So can I write this equation as y1 equal to, what is the value of m? y2 minus y1 upon x2 minus x1 into x1 plus c. Can I write this? Okay, so what will be the value of c in this case? The value of c will be y1, okay, into x2 minus x1, okay, minus x1 into y2 minus y1 upon x2 minus x1, okay, which if we solve becomes y1 x2 minus y1 x1 minus x1 y2 plus y1 x1 upon x2 minus x1, y1 x1 y2 gets cancelled. So the value of c comes out to be y1 x2 minus y2 x1 upon x2 minus x1. Is this clear to everyone? Okay. Now we have seen that we can represent a line uniquely using a pair m comma c. Okay. But now how can we use this pair m comma c to solve our question? How can we use this pair m comma c to solve our question? Okay. So how did we calculate m comma c? We had to use 2 points to calculate m comma c, right? So how will we use m comma c to solve this problem? Can anyone suggest? How can we do that, Himanshu? Please explain. Correct, Rangnath, correct? Correct, Chirag. Your solution is also correct. Please think, how can we use this M and C? Okay, so on so correct. Okay, Raj, against what value? What will be the value? What will be the value, Amit? Correct, your solution is correct, but what will be the value? Correct, Milan, correct. Okay, so let's see with the diagram. Okay, so in this case, as we saw that for this particular line, okay, for this particular line, we had the maximum number of elements falling on that line. Or if we, for this particular line, we found the maximum number of collinear elements. Okay, so can I say, okay, let's first see how we calculate the value of M and C. Okay, so to calculate the value of M and C, we have to pick two elements from that n elements, right? Is this clear to everyone? To calculate the value of M and C, we will have to calculate two elements out of those n elements. right? Okay. And can I also say that for each pair that is falling on this line, or can for each pair that is falling on a given line, the value of the pair M and C will be the same. So can we just count the frequency of M and C for each pair? Okay, and the value of M and C with maximum frequency, okay, will be our line. Can I say that? Is this clear to everyone? Any doubt in this? So I'll repeat what I said. Okay. To calculate the value of M and C, we need to select a pair from those n elements. That is, we need to select two elements. Okay. And for each point or for each pair falling on a particular line, the value of M and C will be same. Okay. So for a given pair M comma C, its maximum frequency will be equivalent to the line on which the maximum number of points will be falling. Okay. So in this case, what we can do for all pairs, okay, for all pairs, okay, sorry. So for all pairs, if we calculate the value of M and C, okay, and if we store this M comma C in a map with our key as this pair, okay, and the value as the frequency, okay, will the maximum frequency of M comma C give us the line with the maximum elements? Once again, please say yes if this is clear to you. Okay, okay. So now let's try to do a dry run on an example. Okay, now let's try to do a dry run on an example. Okay, and the example that we are going to take is 1 comma 1, 2 comma 2, 5 comma 2, and 5 comma 5. Okay, and now what we do, we just try to calculate the value of M and C for these pairs. Okay, we try to calculate the value of M and C. Okay, so first we take the pair 1 comma 1 and we take the pair 2 comma 2. First we take the pair 1 comma 1 and 2 comma 2. So what will be the value of M in this case? 1 comma 1 and 2 comma 2. Use the formula that we have defined, y2 minus y1 upon x2 minus x1. Correct? The value of M will be 1. What will be the value of C in this case? Correct, Vishal, correct today. So the value of C will be 0. Now let's pick up another pair of elements, 2 comma 2 and 5 comma 2. Okay, what will be the value of M in this case? Just use the formula that we have derived. The value of M in this case, correct? Since y2 minus y1 is 0, M equal to 0. And what will be the value of C in this case? Correct, the value C is 2. Okay, let's take another example, 1 comma 1 and 5 comma 5. If you'll calculate, you'll get the value of C as M as 1 and you'll get the value of C as 0. Okay, let's take up another example, the last example. The value, we take the pair 5 comma 2 and we take the pair 5 comma 5. In this case, what will be the value of M? In this case, what will be the value of M? If we try to calculate using that particular formula. Correct. So can I say that in case where x1 equal to x2, okay, in cases where x1 equal to x2, the denominator in our formula x2 minus x1 would be equal to 0. Okay, and if you're trying to solve this using code, we'll get a divisible by 0 error. Correct? We'll get a divisible by 0 error. Okay, so how do we tackle this? So in this case, when we are getting x1 equal to x2, okay, when we are getting x1 equal to x2, let's say we keep the value to be some, let's say instead of infinity, we store any large value. So in this case, let's say we store 10 to the power 18, okay, just for example. Okay, so in this case, we stored 10 to the power 18. Okay, now what we did was we started creating a frequency map for M and C. Okay, so we started creating a frequency map with key as M comma C and value as frequency. Okay, so the first M comma C we got was 1 comma 0. The other one we got was 0 comma 2. The other one we got was 1 comma 0. And let's say the last one we got was 10 to the power 18 comma 10 to the power 18. Okay, since we started this, once we start encountering the pairs, okay, let's say first we got 1, okay, then we got another one, 2, okay, the frequency of 0 comma 2 was 1, okay, frequency of 10 to the power 18 was also 1. Okay, so let's say till here we have the maximum frequency with us as 2. Okay, we have the maximum frequency of M comma C with us as 2 for any given pair. Okay, so can I say that 2 is our answer? 2 is the maximum number of elements that lie on the line. Can I say this? Using STL, you can directly do that. Using STL, you can use that. It is not necessary to have a primitive key type only. Okay. So there are yes and there are some no's. Okay. So for those of you who are saying that this 2 will be the number of elements that lie on that line. Okay. For those of you who see that this 2 will be the number of elements that lie on the line. What is this 2? This 2 is the value of the, this 2 is the frequency of this slope that we got, right? This 2 is the frequency of this slope and the intercept that we got. And when do we get a slope and an intercept? When we select a pair. Correct? When we select a pair. Is this clear to everyone? When do we get a slope and an intercept? When we select a pair from those n elements. Okay. So instead of saying that this is the number of elements, we should be saying that this is the number of pairs that we have selected, number of distinct pairs that we have selected from those n elements. Is this clear to everyone? Others please type. Others please also. Okay. Okay. So if this is the number of distinct pairs, how can we select pairs? How can we select? So there are n elements. What is the total number of pairs that we can select from those n elements? What will be the total number of pairs that we can select from those n elements? NC2. Right? So let's say there are n points that are lying on a line. Okay, the maximum number of pairs that we can select from that element are NC2. Okay, and in that case, that is equal to the maximum frequency that we got here. Is this clear? The maximum number of pairs that we can select from the line, okay, with the maximum number of elements will be equal to the maximum frequency of M comma C. Is this statement clear to everyone? Okay. So NC2 equal to max of frequency. Okay, let's call this as F. Okay, so n into n minus 1 by 2 equal to F, which we can say as n square minus n minus 2F equal to 0. Is this equation clear to everyone? How did we get here? Okay, now we need to calculate the value of n, that is the number of elements on that particular line. Okay, here F is the maximum frequency. Okay, so we get the maximum number of elements on any given line. Okay, Basically, we get the line with the maximum number of elements, sorry. Okay, so what will be the value of n in this case? If we use the quadratic formula minus b plus minus under root b square minus 4ac upon 2a, we get 1 plus minus under root of 1, okay, plus 8f upon 2. Is this clear to everyone? How we got here? Okay, so what we do, for each pair of those n elements, we calculate the value of m comma c and we maintain its frequency table using hash map. At the end of that, we take the maximum frequency value, okay, that will be pointing towards the line with the maximum number of elements, and then we use this formula to calculate the value of n, which comes out to be 1 plus minus under root 1 plus 8f upon 2, sorry. Now, can I say that this particular value will always be greater than 1? Under root of 1 plus anything will be always greater than 1. Can I say this? So, if we take the minus sign here, will this overall come out to be negative? If we take the minus sign here, will this overall come out to be negative? Right? And can n be negative? No, right? N can never be negative. Okay, so what we can do, we can ignore the minus value and we can only take the plus value. So what is the value of n in this case? N is equal to 1 plus under root of 1 plus 8f by 2, where f is the maximum frequency of m comma c. Is this problem or is this solution clear to everyone? Okay. Now there are some, okay, let's first discuss what is the time complexity of the solution. What will be the time complexity of the solution? Correct? The time complexity of this will be n square. Why time complexity will be n square? Because we need to check for every pair. Okay, for every pair we need to calculate the value of m comma c, and then from the hash map we can retrieve the values using order of 1. Okay, so the overall time complexity for this is n square. Now, from whatever solution that we have discussed, okay, from whatever solution that we have discussed, can anyone tell me what are the mistakes that we are doing? Correct, Anup? Correct. That is one thing that we have to take care of. I'll be coming to that. Very good. Can anyone think of, so there are two mistakes that we are doing in this case. Can anyone think of those two mistakes that we are doing? Anup, you have correctly pointed out one of that. Where can that happen? Himanshu? Where can that happen? Not true. There are other two mistakes that we have actually done. Can anyone think of that? Correct, Chirag. Very good. Correct. So, one thing that I asked here was whenever x1 equal to x2, okay, whenever x1 equal to x2, okay, for any pair, we take the value of m and c to be some arbitrarily large fixed value that we have decided. Let's say for now we take it as int max. Okay. Now let's say we had one pair 5, 2 and 5, 5. Now let's say we got another pair 6, 2 and 6, 6. In this case, again we will get x1 equal to x2. Correct? Again we'll get x1 equal to x2. right? And again, if we will calculate using this, we will increment the frequency of 10 to the power 18 comma 10 to the power 18 by 1. Okay. But do these 2 points lie on the same line? Okay. So given this, we have 5 comma 2 and 5 comma 5. 5 comma 2 and 5 comma 5. And 6 comma 2 lies here, 6 comma 5, 6 comma 6 lies here. So do these 4 points, so basically do these 4 points lie on the same line? No, right? This is one line and this is another line. Okay. So can anyone suggest of a better idea, okay, of how we can set the values of M and C in cases where x1 equal to x2? Can anyone suggest of any better idea in how we can set the values of M and C when x1 equal to x2? So if you will observe what is different in this case. Correct, Raman, correct. Correct, Ranganath. So what can we keep as the values of M and C so that we get a distinct pair of M, C, comma C for these two cases? Correct, correct. So some of you have said that instead of uh, keeping uh, both the values as infinite, okay, we can keep one value as int max. Okay, so one value as int max will give us that, okay, for this particular case x1 was equal to x2, and the other value we can keep as the value of x1. Okay, so can I say that for this line, if I keep the value of M as int max, okay, and I keep the value of C as the x coordinate, will I get distinct value of M comma C for distinct lines? Correct? Okay, so in this manner we solved one of the problems. Okay, now can anyone figure out what will be the other problem? What will be the other problem? Okay, so the value of M was y2 minus y1 upon x2 minus x1, and the value of C was whatever the formula that we had, y1 x2 minus x2 y1. Okay, can anyone think of any other problem that we might encounter if we use the pair int comma int for M and C? Yes, Bharti. That's why. So in this case, Bharti, as you saw that since the slope was infinity, that's why we did not keep the value of m1 as x. Okay, the value of m1 will still keep as int max. Only the value of c we will keep as the value of x. Yeah. So Shashi, we cannot set the value of M as X because there can be cases in which we might get X1 equal. Okay. Why not set the value of M to X? Would it be similar? Okay. Negative X1. Okay, let me read your doubts. The lines could also have value of M as X. If x1 is equal to, we need to take absolute. No, we do not need to take absolute. Why not set C to int max and M to the value of X? We're not setting M to the value of X because that will be the incorrect value of M, right? In this case. So the value of slope we are keeping constant. Okay, it's just one what do we call it? It's just one forgot the word for that. So it's just basically it's our decision. Okay, so we keep the value of slope as slope because there can be cases where we can get the value of. So can there be a case where the value of if the value of slope will be infinite? Okay, so let's say okay. Let me just consider one example. Okay, give you the example. Let's say we have this. Okay, and let's say we actually have a line where the y coordinate is int max and the line is like this. Okay, the y coordinate is int max and the line is like this. So what will the value of slope? What will be the value of slope in this case? 0, right? And what will the value of what will be the value of c in this case? What will be the value of c in this case? Shashi? Int max, right? The value of c will be int max. Okay, so to avoid this particular case, we're not doing that. Okay, so whenever we have m as int max, we keep the value of m as infinity in this case. Okay, we get ensured that the slope that we got was so basically the value of x1 was equal to x2, x2 minus x1 equal to 0, and we keep the value of c as x to keep track of which line it is. Okay, now let's come back to the second problem that we were discussing, the second issue with this solution. Okay, so some of you have pointed this out. That the value of m and c need not necessarily be int. Okay, need not necessarily be int. Why? Why the value of? Because it can also be a double or it can also be a float. Okay, double or float, whatever you say. So what can we do instead of using int comma int? We can store it as double comma double or float comma float. Is this clear? We can store it as double comma double and float comma float. Is this clear? Okay, but we do not do that. Okay, we do not want to store the values of our slope and our y-intercept as double and float. Can anyone tell me why we do not do that? Vishal, please reply privately. So if in so it was basically just an example I gave why we took the value of m as int max and c as x. You can do it in the other way also. The other way would also not create any issue. Okay, you can do it the other way. You can keep the value of m as x and c as infinity. That would also create a different pair in this case itself. Correct? So why we don't use double and float? We don't use double and float mostly because we might get a precision error. Okay, we might get a precision error. That is, while rounding off, we might get for two different values of m and c, we might get the same line. Okay, so what is our goal? Our goal is to store the value of m and c as int. Okay, instead of storing them as double and float. Okay, so can anyone suggest me how we can store the value of m or c as integers? Can you suggest how we can store the value of m and c as integers? Correct, Shashi. Correct, Arijit. But how do we store that? How do we store that? No, if we take the floor or ceiling, Chirag, if we take the floor or ceiling, for all the values for this range, let's say if we take the floor or ceiling, so for all the values of, if we take the floor for all the values of 1.0 to 1.9, let's say we get the value as 1 only, right? So for all these different m, we get the same value of m, which is what we don't want. Amit, again, that will be taking into consideration that it can go only till 3.3 decimals or 2 decimals. That is what is exactly precision error. That is, we're not actually considering it to the point where it is getting divisible. Correct. So some of you have given the correct answer. Okay. So how about the value of m if we have in the form of p by q? Okay, how about we store m as a pair of integer? Okay, pair of p comma q. Can we do that? Instead of storing it after dividing the value of p by q, can we store it as a pair of p comma q? That is, can we store m as y2 minus y1, that is the numerator, comma x2 minus x1, the denominator, and can we store the value of c as this is pair, not this. Okay, and can we store the value of c as y1 x2 minus y2 x1, comma x2 minus x1? In this way, can we store? Is this clear? Can we store this m and c as these pairs? Okay. Now let me give you again one problem. Let's say the value of m, okay, let's say the value of m in some case was 9. So let's say the value of m, if we say, was, the points were 1 comma 10 and y2 minus y1 and the point 4 comma 10 and 1 comma 1. Okay, this was one point. Okay, and the other point was 2 comma 4 and 1 comma 1. Okay, in this case, what will the value of y2 minus y1? 9. What will be the value of x2 minus x1? 3. Let's say this was x2 and this was x1. Okay, and similarly in this case, what will be the value of y2 minus y1? 3. What will be the value of x2 minus x1? 1. So if we directly store the value of x2 minus x1 and y2 minus y1, will we identify these two as different pairs of m and c? Will we identify these two as different pairs of m and c? Right? But are these two the same pairs? So for m, I'm saying, for m, will we identify these two as different pairs? Okay. And are these both same? Yes, these are both same. So how do we do that? How do we remove these cases? We can divide by the greatest common denominator between 9 and 3, right? Correct? Most of you have already guessed it. We can divide by the GCD of 9 and 3. Okay. So how we can do that? We can do that. The value of m will be y2 minus y1 upon GCD of numerator and denominator, comma x2 minus x1 upon GCD of numerator and denominator, and the value of c will be similarly the numerator upon GCD and the denominator upon GCD. Okay, is this clear to everyone? This is the final solution. Okay, now what is the space complexity in this case? What is the space complexity in this case? In worst case, what will be the space? Let's consider the worst case. What will be the space complexity in this case with this solution? No, Raj, not correct. Amit, correct. What will be the space complexity in this case, guys? Correct, correct. Bharti, correct. Milind, not correct. Utkarsh, correct. Prashant, correct. No, Vishal, not correct. And reply privately. Please change it to me instead of replying to everyone. Just Chirag, correct. Anup, correct. Okay, so the space complexity in worst case will be order of n square. Why order of n square? Because from n, we are trying to select two elements. Okay, from n, we are trying to select two elements. And let's say for each element, we get the value of, for each pair, we get the value of m and c different. Okay, we get a unique value of m and c. Okay, so how many total number of m and how many total values of m and c we will get? It will be equal to the total number of pairs, that will be equal to nc2, which will be equal to n into n minus 1 by 2, which is nothing but order of n square. Is this clear to everyone? Order of n square? Okay. Okay. Now, to solve this problem, what is the best time complexity that we can get? Can anyone try to guess what is the best time complexity that we can get to solve this problem? Not from the solutions that we have discussed, but try to guess, is there a solution possible? Is there a better solution possible where we can improve the time complexity from order of n square? No, not for any particular special case. Not for any particular special case. Okay. So the answer is no. The time complexity cannot be further improved from order of n square. Why? Because to form a line, we need to select two pairs and we need to check for all the two pairs. Okay, that will be the case. Okay. But can we improve the space complexity? Can we improve the space complexity? Can you think of how we can improve the space complexity? Okay, so I'll give you a direction to think. Okay, right now we were representing a line using m comma c. Okay, we were representing a line using m comma c. Okay, so this m comma c comes for every pair. This m comma c comes for every pair. Now, can you think of any other parameters how we can store the information about a line? Can you think of any other parameter about how we can store or how we can uniquely distinguish any particular line, or how we can uniquely define any particular line? Can anyone think of a solution? You're a little bit correct, Prashant. You're a little bit correct. So that's what we are already doing, right? With slope and c. M is the slope and c is, that is what we are doing, right? Prashant, you're correct, but a little bit wrong. Okay. So let me tell. Okay. So it's a 2D plane. Okay. Let us fix any particular point P1. Okay. Let us fix the point P1. Okay. So for this point, can I say that for this particular point, there is only one line possible with any given slope? Can I say this? For this particular point, if this particular point lies on a line, can I say that there is only one possible line through this point with that given slope, any given slope? So can I uniquely define any line as a pair of any point P1 comma a slope? Is this clear to everyone? Can I do this? Okay. Okay. Cool. And how do we find the slope? How do we find the slope? To find the slope, we need to require two elements, or we need to require 2 points. Okay. So I've given enough hints from this particular solution that I have found. Can anyone think of a proper solution on how we can improve the space complexity from order of n squared to solve this particular problem? Please try to think of a solution. Okay, we're representing a line using any point and its slope. Okay, and we need to use 2 points to find the slope. How can we do that? No, we don't need to do that. We don't need to do that. We don't need to assume the second point as origin. Okay. Okay. Let me tell the solution then. So can I say for all points P, okay, for all points P, okay, if I iterate, okay, for all points P, if I iterate over all points, for all point P1, if I iterate over all points P2, okay, and if I find the value of M, okay, and if I maintain a map with M as the key, okay, and the frequency of how many times that M has occurred as the value in that map, will I be able to count the number of points, okay, for that particular M? Will I be able to count the number of points with which that particular M was obtained? I'm waiting for others to reply. Only 4 have said yes. Others, do you have a problem with this? Please say yes if it is clear to you. If it's clear, please say yes. Okay. So for all points P1 and for all points P2, if I keep a map of M and frequency, okay, I get the value of M with maximum frequency. Okay, that is for any point P, I get the value of M with maximum frequency. Okay, and that M will be obtained with when I form a pair with all the elements that are a part of that particular line. Okay, so can I say that the value frequency is equal to the number of elements that are on that line? Can I say this? The value of frequency is equal to the number of elements that are on that line. M can be same for parallel lines, Raj Kiran, but that M, in case of parallel lines, if you're trying to say, okay, let's say there are two parallel lines, and if we try to take this point here, okay, if we try to take this particular point here, okay, so this particular point, for this particular point, will you get the value of M as same for these points on this particular line? No, right? Rajkiran, is this clear to you? Right? So what we're trying to do is we're trying to find the maximum value of frequency for each P. Okay. So for each P, we are trying to find the maximum value of P, and our answer will be maximum of all those maximum values. Okay. Is this clear? Is this clear now, Rajkiran? Okay, so for each element, for each point, what we are trying to find, for each element, we are trying to find a given line, okay, on which that particular point lies, okay, and that line also has the maximum number of elements present on it. Okay, so let's say we are given total n lines. From these lines, we first select all those lines on which that particular point P1 is lying, and amongst those P1 we try to find that line with maximum numbers on it. Okay, is this solution clear to you? Is this solution clear to everyone? Okay, now how we will do this in order of n space complexity? How we will do this in order of n space complexity if we are again traversing two loops? Can anyone tell how we can do this in order of n space complexity if we are traversing two loops? Correct, 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 correct. Rangnath also correct, Anup also correct, Amit also correct. So can I say that once I check for any point P1, once I check for any point P1, okay, the value of frequency for any given n m will not be useful for me if I check for the other point P2, if I check for any other point P2, right? So after iterating for all the values for a given point, can I clear this map and just take the maximum value and store the maximum value from it? Can I clear the map after each iteration? Yes. After each iteration, I'll be getting the maximum value of, I'll be getting the maximum number of collinear elements with that given point. Okay. And at the end, I'll be getting the maximum number of collinear points. Okay. So after each iteration, what I will do, I'll clear this map. Okay. So the overall space complexity that we used was only order of n, even if all the elements are giving different values of m for any given p1. Can you be getting confused? Okay, okay, I'll just repeat this again from the beginning. Okay, so was this clear to you, Milind, that we can represent any given line as any point and a slope? Right? We can represent any line as any given point and a slope. Okay, so you're given a line. Okay, you're given a point. For this point, you calculate the slope with all the other points in that plane. Okay, you calculate the slope with all the other points in that plane. That is, you calculate the value of m. Okay, for all the points that are lying on a single line, will the value of m be same? X2 minus y2 minus y1 upon x2 minus x1, y2 minus y1 upon x2 minus x1. Will this be same for all the points that are lying on a given line that passes through the point P? Why no? Yes, yes. Now it's correct, right? So if that line passes through P, the value and all the elements lie on that line, the value of slope will be same. Correct? So if we maintain the frequency of M, if we maintain the frequency of different M for that particular point P, okay, will the maximum frequency give us the line with the maximum number of elements? Yes. Now, once we got the line with the maximum number of elements with P1 lying on it, can we clear the map? Because for the next point, we will again have to calculate the value of M with each and every distinct point. So can we clear this M and just store the maximum value of numbers on that line? Is this clear now? Okay, cool. Okay. Again, most of you again guessed wrong in one case. Okay. So when I asked that will the frequency be equal to the number of elements, all of you said yes, not a single one of you said no. Okay, so the frequency will not be equal to the number of elements lying on that line. Can anyone tell me the number of elements lying on that line? There's just a slight modification to the frequency. Okay, we just forgot a small thing. Correct, Amit? Correct, Prashant? No, in this case, frequency is not pairs. I'm talking about the second solution, Chirag, not the first one. In the first one, the frequency was pairs. In this, the frequency was the number of elements. Correct, Ankit. Correct, Rajesh. Okay. So let's say for any element P1, if we're trying to calculate the value of slope, okay, if we're trying to calculate the value of slope, we will take all the elements other than that particular element P1, right? So did we forget the element P1? P1 is also lying on that line, right? So what will be the number of elements? The number of elements will be frequency plus 1. That is the element itself. Is this clear to everyone now? Okay. Okay. So the time complexity was order of n square and the space complexity was order of n. Okay. Any doubt, dry run with this method? Okay, we can try to do a dry run with this method. How many of you want to do a dry run with this method? So Chirag, will it be okay if I do the dry run at the end? Will that be okay if I do the dry run at the end? Okay, cool. Remind me in the doubt session, I'll explain this problem with the dry run, okay? No, that won't be that won't affect the time complexity because, no, it won't be a part of the time complexity. It can be done in order of log n. Okay, I don't remember the algorithm, Anup. I don't remember the exact algorithm, but it can be done in order of log n time. Okay, I'll look at it. Yes, order of log n. So between n and log n, which is greater? Correct. So that's why overall time complexity will be n. Okay. I'll explain this again at the end. If you're still having a doubt, I'll explain this again at the end. Okay, that won't contribute to the time complexity. I'll explain it at the end how it won't contribute to the time complexity. Let's take the next question for now. Okay, so again it is a geometrical question. Okay, so let me add a bookmark. Okay, you're given a 2D plane. You're given n points. Okay, on the 2D plane, and you need to find right angle triangles. Okay, you need to find right angle triangles such that the smaller sides, okay, the smaller sides are parallel to the x-axis and y-axis. Okay, so you need to find the right angle triangle such that the smaller sides are parallel to the x-axis and the y-axis. What are the smaller sides? So if this is a right angle triangle, this and this are the smaller sides, and these sides needs to be parallel to the x-axis and the y-axis. Okay, so what are the 4 cases of a triangle that can be formed? Either it can be in this orientation, either it can be in this orientation, either it can be in this orientation, okay, or either it can be in this orientation. Okay, is this clear to everyone? Is this problem clear to everyone? I'll explain with an example also. Okay, so we need to count the total number of right angle triangles that are possible. Okay, for which the smaller sides are parallel to the x-axis and the y-axis. Okay, so let's take a very small example. Okay, so take 1, 1, 2, 1, take 4, 1, take 1, 3, and take 4, 3. Okay, so these are the points. The points are 1, 1, okay, 2, 1, and this is 4, 1. Then we have 4, 3. Then we have 1, 3. Okay, so let's take an example for this 1, 3 only. So how many such triangles are possible? If you look, only one of such triangle is possible where the sides, smaller sides, will be parallel to x-axis and y-axis. Okay, for this, if we take, this is one triangle that is possible. This is also one triangle that is possible. Okay, so are you getting what the question is trying to ask? Is the question clear to everyone? Please say no if you have. Please say no if the question is not clear to you. If the question is clear to you, please say yes. Okay. 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 How will we solve this problem? How will we solve this problem? Something like that. Something like that. But what will that eventually lead to, Adi? What will that eventually lead to? Okay, so try to think like this. For every solution, how do we start? We start with the brute force approach. Okay, so start with the brute force approach. Start with the brute force approach. Okay, what is the brute force approach? How many elements or how many points are required to like build a triangle? So for a line, 2 points were required. How many points will be required for a triangle? Amit, your answer is correct. Can be done in a better time complexity, but your answer is correct. Okay. So please answer the question that I've also asked. So for a triangle to be formed, we need to find 3 points. Okay. Okay. Yes. Again, Chirag, your answer is also correct. No, Rangnath, not this way. Not this way. We will not be proceeding this way. Okay. So let's say we have 3 elements. Okay. P1, P2, and P3. X1, Y1, X2, Y2, and X3, Y3. Okay. Now let's say the right angle is formed at the P2 point. Okay. So let's say the right angle is formed at the point P2. That is X2, Y2. This is X3, Y3, and this is X1, Y1. Okay. So from the given information in the question, that is these lines are parallel to the X and the Y axis, can we derive any conditions between these 3 points? Can we derive any conditions between these 3 points? Correct? Correct? Can we derive any conditions between these 3 points? Correct. Amit correct. Saumitra correct. Ranganath correct. Okay, so what are the conditions that we can define? Since this line will be parallel to the y-axis, can I say that the x coordinates of these lines is same? So we don't need to go and use the Pythagoras theorem. That will increase the time complexity. We don't need to go till there. Can we say x1 will be equal to x2? And since this line will be parallel to the y-axis, can I say y2 is equal to y3? Or just let me change this a little bit. Can I say this x2 equal to x1 and y2 equal to y3? Yes, Vishal, your solution is also correct. Yes, Milind, your solution is also correct. Okay, yes or no, can we write this condition? Okay, okay. So can I say that if we are given, sorry. So can I say that if we are given 2 points x1, y1 and x3, y3, okay, that is for all p1, for all p2, we need to look for an element x2 and y2 such that its x coordinate is equal to x1 and its y coordinate is equal to y3. Can I say this? Is this clear to everyone? So what I'm trying to say is for all elements p1, for all elements p2, okay, what I see is I iterate over the array and I try to find for an element for which I try to find for an element x2 where the right angle is formed such that the value of x2 is equal to x1 and the value of y2 is equal to y3. Correct? So what will be the time complexity in the brute force approach? What will be the time complexity in brute force approach? Correct. Ashish, Rangnath, not correct. Rajkiran, correct. Prashant, correct. All of you are correct. The time complexity will be order of n cube. Okay. Now, can we improve this time complexity from n cube? Can we improve this time complexity from n cube? So we have to search for all elements p1 and p2, but can we improve the other n searching time complexity where we have to look for the element x1, comma y3? Can we improve this? Correct, Rangnath, correct. Can we improve this searching? How? How? If yes, how? Yes, Samitra, your solution is correct. So can I say that if initially I store all points, okay, if I store all points in a hash set, okay, if I store all points in a hash set, then for all P1 and for all P2, to look for this particular element, it will take me only order of one time to see if this particular element is present or not. Is this clear to everyone? Okay. 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 So what will be the overall time complexity in this case? Order of? Correct? Correct? So the overall time complexity in this case is order of n square. Why? Because we have to iterate over all P1 and all P2. Okay. Now, will the number of elements that we get here, so let's say for x, so for all P1 and for all P2, okay, we try to find if we get this particular element or not, and the number of times we get this element, we increment our count. So will that be our answer? Will that be our final answer? One, two, no. One, yes. Please, everybody vote. Will that be our final answer? 32 people, 3 votes, 4 votes. Okay. So what my question was that for all P1 and for all P2, we try to look for that element, and if we find that element, we increment our count. Will that be our final answer? This was my question, Anup. So what is your answer? Please reply yes or no. Will that be our final answer or not? Okay. So there are 5 yes and 5 no. Ranganath is saying count -1, which I'll again come to know. Okay. So one thing is, while we are iterating over for all P1 and for all P2, okay, will there be repetition for each case? Will there be repetition for each case? That is, for a pair P1 comma P2 also we will find x1 y3, and for a pair P2 comma P1 also we will find the pair x1 y3. Yes, is this clear to everyone? So again, will our answer be answer by 2? Will this be our final answer? Okay. So let me take an example. Let us try to do a dry run and see if this is our answer or not. Okay. So let's say we have a triangle with this element as 0, 0, this is 1, 0, and this is 1, 1. Okay. Now, what we do, we pick 2 elements. Okay. What are the 2 elements that we pick? We pick 0, 0, and we pick 1, 1. Okay. For 0, 0 and 1, 1, okay, this is our P1 and this is our P3. Okay, x1, y1 and x3, y3. Okay, and the element x2, y2 that we have to find is x1, y3. Okay, so the element that we have to find is 0, 1. The element that we have to find is 0, 1. Correct? So do we have a 0, 1 here? We don't have a 0, 1 here. So we move on. Now what we do? We have searched for 0, 0 and 1, 1. Now we search for 0, 0 and 1, 0. 1, 0. Okay. Again, what we have to find? We have to find the value of x1 and y3. So what is the value of x1 and y3? The value of x1 and y3 is 0, 0. What did we got? We got 0, 0. Do we have a 0, 0 in this space? Do we have a 0, 0 in this space? Yes. So should we increase our answer by 1? No. Why? Because the points 0, 0, 1, 0 and 0, 0 if we take will form a straight line. Is this clear? The point 0, 0, 1, 0 and 0, 0 will form a straight line. Right? Please try to reply yes, so that I can be clear that it is clear to the people and I can move on and not spend much time on this. Okay, if you'll try, if very few people will be writing yes, I'll think that it's not clear to you and I'll try explain it again. So it's just a matter of pushing one button. Okay, please click on yes so that I can be sure that it's clear to you. I can move on. Okay, so what are the conditions that we have to see? The conditions that we have to see in this case are repetitions and same lines. Okay, so there are too many if checks involved in this solution. Okay, we can come upon those if checks. Okay, but there are too many if conditions that come into play. Okay, so this is not a very good solution for this problem. Okay, so can anyone think of any other solution? Can anyone think of any other solution? Some of you have already guessed that solution. Some of you have already guessed that solution. Okay, so let me give you a small hint. Okay, let's say this was our point P1, this was our point P2, this was our point P3, this was our point P4, this was our point P5, P6, P7, P8 and P9. So for this particular point P1, if we take P1 as the point, so in the previous solution what we were taking two elements, okay, where the right angle was not formed. In this case what we will take the element where the right angle will be formed. Okay, so from this condition, can anyone say with P1 as our right angle, how many triangles are possible in this case? Can anyone say that with P1 as our right angle, how many triangles are possible in this case? No, Amit, not correct. Okay, so let's try to see how many of them are possible. One is this. Okay, second one is this, 3 and 4. Again, for this point also 1, 2, 3 and 4. For this point also 1, 2, 3 and 4. Okay, for this point also 1, 2, 3 and 4. Okay, Ankit, your solution is correct. Vishal, your solution is also correct. Ankur not correct, Bharti not correct, Rajesh not correct. So what are the total number of triangles that are formed in this case? 16. Is it clear how 16 triangles are formed? So for this given P1, whenever we take an element on the x-axis and whenever we take an element on the y-axis, okay, with respect to this P1, we get one right angle triangle where P1 is our right angle. Is this clear? Right? So can I say that for all the elements on this axis, okay, for all the elements on this axis, their y coordinate will be equal to, let's say if it's the coordinates of P1 are x1 and y1. So for all the points on this line, its y coordinate will be equal to y1. Can I say this? Now, for all the points on this line, can I say that their x coordinate will be equal to x1? Okay. So can I say that the number of triangles for any element P is equal to the frequency of elements on the x-axis into the frequency of elements on the y-axis? Can I say this? Again, there's a small thing. We need to subtract 1 from both of these. Why? Because we need to remove the point P1, because for P1 also it is lying on this particular line and this particular line. Is this clear why we are subtracting 1 from both these solutions? So can I generalize this that for any element P whose coordinates are x1 and y1, okay, the number of triangles formed are equal to the frequency of element or the frequency of x1 minus 1 into the frequency of x2 minus 1. Does anyone have any doubt in this frequency of x1 minus 1 into, sorry, this is y1, not x2, frequency of y1, that is the y coordinate, frequency of y1 minus 1. Correct? Now, how can we solve this problem? How we have arrived at this? How can we solve this problem? How can you solve this problem? Correct, Anup? Correct, Amit? Correct, Rangnath? Again, correct. Others also, please try to think how we can solve this problem. Most of you have already given the answers. For those of who you, yeah. Correct, Vishal. Vishal, very good. Correct. So, before starting to solve the problem, can I create two hash maps? Okay. One having the x coordinates as key, okay, and the frequency of those x coordinates as the value, and the other one having the y coordinates as key and the frequency as its value, okay, and then I iterate over all the elements just once, okay, and our answer plus is equal to, okay, x, let's say this map is x and this map is y. So x dot get the value of x1 minus 1 into y dot get the value of that y1 coordinate minus 1. Will this be our answer? Okay, correct. This time I won't be confusing you. This is the final answer. Okay. In this solution we don't have any repetitions or any cases. Okay. Now what is the time complexity in this case? What is the time complexity in this case? Correct, Amit? Correct, Chirag? No, Chirag, not correct. Prashant, correct. Adil, correct. No, Ankit, we don't have to divide by 4 because we are iterating over all the elements only once, and we are checking only for those cases where that element will be where that element will be forming the right angle. Correct, Amit, Rangnath, correct, Ankur, correct. So the overall time complexity is order of ny, because once we are iterating over the array to form the frequency array, and then once we are iterating over the array to check the number of x1 and the number of y1 that is present in the given 2D plane. What is the space complexity? What is the space complexity in this case? Correct, 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 everyone. So the space complexity is order of 2n. Why? Because we are storing two maps. Okay. So in case where all the elements are distinct, the space complexity can be order of 2n. That is overall order of n. Okay. So this is much better than the solution that we discussed previously, because that was an order of n square solution. Along with n square, it was also giving us so many if and else condition. But this one is an order of n solution with order of n space complexity. Okay. Is this clear to everyone? Shall we move on? Yes, please. Yes from everyone. Shall we move on? Okay. Let's take up another question, the last question for tonight. Again, we are giving a 2D plane. Again, we are given a 2D plane. Again, we are given n points on that 2D plane. This time, instead of a triangle, we need to find a rectangle. Let me add a bookmark. I always forget that. Okay, the bookmark is added. Okay. So what we need to do, we need to count the number of rectangles, okay, such that sides of rectangle are parallel to the x-axis and y-axis. Okay. Again, taking an example, 1, 2, 3, 4, 5, and 6. This is minus 2, comma 3. This is minus 2, comma 1. This is 1, comma 3. This is 1, comma 1. This is 3 comma 3. This is 3 comma 1. So in this case, again, as you can see, we have 1, we have 2, and we have 3 rectangles possible. Okay, for which the sides of the rectangle are parallel to the x and the y axis. Okay, think of a solution for this problem. Start with a brute force approach. Okay, start with the brute force approach. We have 4 points. Let's say we have 4 points here: P1, P2, P3, and P4. X1, X2, X1, Y1, sorry, X2, Y2, X3, Y3, X4, Y4. What can we say about the relationship between these 4 elements? What can we say about the relationship between these 4 elements? Yes, a square is counted as a rectangle. So for a box with 1 unit area, also the value of, so in a 2D plane, even if you want to consider a box with 1 unit area, all the 4 coordinates will be different. Is this clear, Ashish? Okay. So can you find the relationships between these 4 coordinates? Correct, Ankur? I'm not sure about your solution. We can look at your solution. Okay, so x1 equal to x4, x4, y1 equal to y3, and okay. Yes, Anup, your solution is absolutely correct. Others also please try to write. Others also please try to write the conditions for this. Just take 20-30 seconds more maybe. What will be the conditions for these? Some of you have already answered. Soumitra, I did not get your solution. Okay, so once I explain these conditions, I'll unmute you. Please explain your solution to me and then we can discuss. I'll unmute you. Just give me 2 minutes. Okay, so the conditions that we can come from this problem, the conditions that we can derive from this problem are, since these two are on the same line, okay, P1 and P2 are on the same line, can we say Y2 equal to Y1? And similarly, since these are on the same line, can we say Y4 equal to Y3? Okay. Again, for x coordinates, if we see these two are on the same, these two are parallel to the y axis. So can we again say that x4 is equal to x1? And this is also parallel to the y axis. So can we say x2 is equal to x3? Is this clear to everyone? Are these 4 conditions clear to everyone? Okay. So can we say that we have x1 y1 here and x3 y3 here, that is we have p1 and p3 here. Okay, we have p1 and p3 here. Okay, so for all elements p1 and p3, so that is what I'm trying to say is, for each diagonal pair, can we try to find another diagonal pair with the values that we have derived from this formula? So what will be the other 2 diagonal pairs for this pair? The other 2 diagonal pair will be x4, y4. x4, y4 is x1, comma, the value of y4 is y3, and x2, y2. So x3, comma, y1. So we need to look for these elements. Okay. Is this clear to everyone? Is this clear to everyone? Correct. Now, if in this case also we are looking for elements, can we use a hash set? So can we initially keep all the elements in the hash set, and while searching we can use a hash set? So what will be the overall time complexity in this case? What will be the overall time complexity in this case? Correct. Answer please. Others also try to answer. What will be the time complexity in this case? Correct. All of you are correct. Time complexity will be order of n square. Why? Because we are selecting two elements. So for every P1, for every P2. Okay. Now again, in this case, if we directly find the value of P1 and P2, that is, we check for all P1 and P2, will there be some repetitions? Will there be some repetitions in this case also? Okay. So what can we do to avoid those repetitions? Can anyone tell? What can we do to avoid those repetitions? So the two repetitions that are possible are, okay, the two repetitions that are possible are same as the previous case, that either we get a repetitive case, that is P1 and P2 are same. That is a repetitive case. By repetitive case, I mean is once we take P1 and P3 as a pair, and for the other time we take P3 and P1 as a pair, and we search for them. And the other case can be where all the four elements lie on a single line. So can we think of any condition that we can add so that we avoid these two cases? Can we think of any condition that we add on these x1, y1, and x3, y3 so that we avoid these cases? Yes, that will avoid the line. That will definitely avoid the line, Adi. But that will not avoid the repetition. That will not avoid the repetition. Can anyone think of anything better? I'll explain that also. That will also be covered. That will also be covered. No, Ramnath, not this condition. This will only ensure that we do not get a line. This will only ensure that we do not get a line. So do you know a way to select those two lines, Chirag? Do you have a solution for that? How we can select those two lines? That will again be a different n square solution where we have to search for those two lines, right? If we try to solve it in that way, there we had a advantage that we were selecting that particular element for which the right angle was being formed, but we won't have any such advantage in this case, Chirag. Okay, so what if I fix okay, so what if I fix the element that comes, what if I fix the element that comes about diagonally? So if we have a rectangle here, okay, if we have a rectangle here, what if I fix the element that comes above? So let's say I take P3 as the element that comes above and P1 as the element that comes before. So how I can specify this case? How I can specify this case? Let's say for this condition to be true, x3, y3 and x1, y1, for this condition to be true, if we take y3 greater than y1 and x3 greater than x1, okay, will we avoid all the repetitions? Will we avoid all the repetitions? So to answer, one question that was being asked before was, yeah, So Anup, you asked that P1 and P3. So for P1 and P3, if there exists a P2 and P4, and in the other way, the repetition that for P2 and P4, if we check for P1 and P3. So will these conditions avoid that repetition also? Right? Okay. So if we specify these two conditions, okay, and for all P1 and for all P2, okay, we check for the above elements that we found. We check for these two elements. Where are these two elements? Yes, x1 y3, x1 y3 and x3 y1. Okay, in order of one time from using hash map. Will we get our answer? Will we get the number of rectangles that are possible? Please say yes if this is clear. Please. Okay. So what will be the time complexity for this? What will be the time complexity for this? Correct. Correct. I mean, what will be the time complexity for this, guys? Correct, Ankit. Correct. Prashant also correct. So the time complexity of this will be order of n square. Why? Because we are iterating for all P1 and for all P2, and the search for the element is order of one operation using a hash set. Okay. Now look at some of the solutions that were given to you. Store all points on X. Okay. Store all X array of Y. Okay. Okay. So let me come to the solutions that you will have given. Storing only X and Y individual is worth. You can assure 2 points using the same, right? Without going, you need to assure its existence. So Amit, your solution was right till where we were storing the elements, but we cannot assure the third point. Store all X slash Y. So X1 array of. Okay, Amit, you did not understood how we avoid P2 and P4 are as the condition. Okay, I'll explain that. Vishal, what you are suggesting is that we count the number of vertical lines and we count the number of horizontal lines. Okay, and multiplication of horizontal lines C2 and vertical lines C2 should be our answer. So to calculate the number of horizontal lines, okay, again you will have to calculate for all P1, for all P2. Okay, for vertical lines also you'll have to calculate for all P1, for all P2. Okay, so you're repeating the same process twice to calculate the number of vertical lines and the number of horizontal lines. Yes, Anup, I'll be explaining this. So Vishal, is this clear to you why we are not using that? Yeah, that approach is also clear. That approach will also give you the correct answer. Okay, number of vertical lines C2 into number of horizontal lines C2. That will also give us one rectangle. Okay, so Anup, let's say we are given this triangle. Okay, X. Sorry, P1, P2, P3, and P4. Okay. Now, if we specify the condition that x3 is greater than x1, okay, and x2 is greater than x3 is greater than x1 and y3 is greater than y1, Okay, so in this we are considering the condition in which the diagonally, so we are considering the pair where this is uh, this is the diagonally lower and the element towards the left, and this is the diagonally uh, so higher but the element towards the right. Okay, will this be ensured with this condition, Anup? Yes. So let's say for P4 and P2, okay, if we take P4, it is our higher element, that is Y3 will be greater than Y1. Okay, if we take P3 as, so if we take this as P3 and if we take this as P1, that will be the opposite case, right? So in that case, Y3 is greater than Y1, but is X3 greater than X1? No, right? And even if we take the opposite way, if we take this as P1 and we take this as P3, okay, in this case, X3 is greater than X1, but is Y3 greater than Y1? No, right? So you got how we will avoid the repetition in this case? Okay. Okay. So that was all the questions that we had to discuss today. That was all about the questions that we had to discuss today. Now there's one small algorithm that is left, Rabin-Karp string matching algorithm, which also uses hashing. Okay, which also uses hashing to solve any problem. Okay, but I don't want to explain that algorithm in a hurry. Okay, uh, like it's a very interesting algorithm. I can cover that in 20-25 minutes very easily. You'll get the explanation, but like should be explained in it should be explained in more time. Okay, so what I will do is I don't know, may not give solution. Okay, so let's consider your case, what you're trying to say. 0 comma 0, 1 comma 0, x is 1 and y is 0, 0 comma 1, 2 comma 1, 2 comma 1, and 1 comma 2. X is 1 and y is 2. So in this case, these two pairs will give us a horizontal line. Okay, and so we fix one element. For this element, this is giving us a vertical line. Okay, number of horizontal lines. We can extend the class. Okay, so how many of you want that I cover the Rabin-Karp algorithm today? And how many of you want that I cover the Rabin-Karp, like I schedule one class, one extra class maybe for the Rabin-Karp algorithm? It's a very interesting string matching algorithm. Okay, and there's a very good question based on that. It's kind of like 50-50 only. So what I'll do is I'll schedule a very small class. So it will be a 1 hour class. Okay, just for a discussion on Rabin-Karp string matching algorithm. Okay, it should have been taught separately. Okay, it should have been taught separately, but it was included as a part of hashing. Okay, but these solutions took a little more time than I expected. Okay, so yeah, from the solution that you guys suggested, that we can also count the total number of horizontal lines. Okay, so Ankit, the total number of horizontal lines, okay, C2, okay, into the total number of vertical lines, C2 will give us the answer, okay. But what will not give us the answer is the total number of, like the one that we solved in the previous case, that is the frequency of x minus 1 into the frequency of y minus 1. Okay. Why? Because that will create the case that you are looking for. Okay, that will create the case that you are looking for. But even in this case, if you try to look for the frequency of the vertical lines, so there are two vertical lines and two horizontal lines, and the number of ways in which you can select two lines out of two will be 2C2 into 2C2, which will eventually be equal to 1. Okay, that will be a different class. Knuth-Morris problem will be taught separately. That will be a completely different class because that is not related to hashing and all. KMP will be taught in a different class. That will be related to string matching, I guess. If not necessary, that it's not necessary that horizontal and vertical interact and form a rectangle. If there are two horizontal lines and two vertical lines in a plane, okay, if there are any two horizontal lines in a plane and there are two vertical lines in a plane, they will always interact at some 4 points because lines are infinite. Okay, what will not give us the answer is that no horizontal into no vertical rows may not, but we are not, but we are given points, not lines. Yes, Ankit, some of you suggested that we can calculate the number of lines. Okay, so in this case, again, we will have to consider a lot of repetitions because let's say if this is the plane and there are 3 points that are lying on the same plane, so one line can be found using these 2 points and one line can be found using these 2 points. So we have to consider this as 1 and not 2. Is this clear now, Ankit? Will this give the right solution? Okay, sorry, let me take your solution. Let me take your question again. Okay, your question is 0, 0. There is 1 point. There is 1, 0. There is 1, 0. Okay, there is 0, 1. There is 0, 1. Okay, and there are 2, 1. Then there is 0, 1, and there is x is sorry. I'm sorry. I'm not drawing the lines correctly. Okay, 0, 0. Then we have 1, 0. Okay, then we have 0, 1. Then we have 2, 1 and 1, 2. Okay, so this is 2, 1. Okay, and somewhere here will be 1, 2. Okay, now in this case, if you see that there will be one line which will be formed using this. Okay, and there will be one line which will be found using this. Okay. I get your point. I get your point. I get your point. Correct. Absolutely correct. So, absolutely correct. So the solution NC2 into NC2 will not. So basically, XC2 into YC2 will not give us the correct answer. XC2 into YC2 will not give us the correct answer because in that case we might get points where the rectangle is being formed and the intersection point is not given to us in our data set. Okay, as suggested in this case. Okay, so if we selected these two and these two, we are getting a rectangle. Okay, but according to the question that is given to us, either our rectangle should be formed using these points. Okay, our rectangle should be formed using these points and not the lines that are formed by these points. Is this clear now why XC2 into YC2 solution won't work? Okay. Thanks, Ankit. Thank you for suggesting and correcting me here. Thank you for correcting me here. Okay, so what I'll do is tomorrow I'll have a discussion with Kshitij and I'll schedule a 1 hour class for discussion on Rabin-Karp string matching algorithm. Okay, so before I end today's class, I'll just give a problem statement that is related to that. So the problem statement is that you are given a string. Okay, let's say the string is A, B, C, A, B, D, E, A, B, C. Okay, and let's say you're given a pattern B, C, A. Okay, what you have to do is you have to search for occurrences of this pattern in this string. Okay, so you have to search for occurrences of this pattern in this string. Okay, so I'll give you direction to think. One will be a brute force approach. Okay, try to think from the brute force approach. Then in the brute force approach, what we are doing is we are actually comparing elements. So try to think of any other property that we can compare instead of directly comparing the elements. Okay, and how we can reduce the number of comparisons. Okay, KMP is faster, but there are cases where Rabin-Karp will be beneficial. Okay, I'll discuss those examples also why Rabin-Karp is used somewhere instead of Longen, that is GCD will not contribute to my first problem. Okay, sure. I'll discuss that once I start the doubt class. One second. Just 1 second. Okay, sorry. And we can discuss that it is related to string. Can you discuss why log and GCD will not contribute to the first problem? Yes, we can. I have an interview problem. When can I discuss that it is related to string? It requires pattern searching. So, Milind, what I'll say is that if it's a general pattern searching where you have to look for a pattern in a given string, then always KMP will be beneficial. Okay, and if you have to look for K patterns in a given string, okay, if you have to look for K patterns in a given string, in that case, Rabin-Karp is beneficial. So try to solve that question with this given piece of information. If not, you can post your question here and I can look at that question. Anup, I'm sorry, I'm not aware about this. Okay, I'm not aware about how the time complexity for GCD actually. I'm sorry. So I'll look at that. Okay, I'll look at the time complexity of GCD and I'll discuss this problem in the next question, next class. Okay, how GCD will not contribute to the time complexity. Okay. I'll discuss this problem in the next class. So I'll stop the class here. Okay, I'll start the doubt session here. One of you wanted a dry run on one of the cases. Okay, please stay. I'll start with the dry run for that particular case. Okay, I'll start with the dry run for that particular case. And I'll schedule one extra class for the discussion on Rabin-Karp string matching algorithm. Okay, so Anup, I'll discuss this problem in the start of the next class. Sorry, I don't know about this. Okay, I'll discuss this in the start of the first. I'll discuss this in the start of the next class in the extra class. Okay. Just can the person please reply who wanted to have a dry run on that case? Can that person reply who wanted to have a dry run? Okay, Chirag, yes. So what was the question you wanted to have a dry run on? Can you please repeat? first question of collinear points. Okay, so in the first question you wanted to, okay, y equal to mx plus c, and in the last solution you actually wanted to have a dry run. So the last solution was where we actually, yeah, where we were saving the space and we were doing it for m points. Okay, okay, cool. 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 So let me take an example that will help. I might already have an example. Okay, cool. So let's take an example. Complexity order of n square. In this case, the time complexity was order of n. So let's take the same example that we took. Okay, so the n points that are given to us are 1, 1, okay, 2, 2, 5, 2, and 5, 5. Okay, now what we do, we take this 1 point. Okay, so the p we take here is 1, 1. Okay, and what we will be doing, we'll be maintaining a map. Okay, we'll be maintaining a map of the slope versus its frequency. Okay, that was what we were doing in this question, right? Correct, Chira? Okay, so if we start with 1, 1, okay, and we take this element 2, 2, what will be the slope in this case? No, not in this case. Not in this case. For a line, we always have to select two distinct elements. Okay. So in this case, the slope will anyway be 0. So for all the elements, we'll get the slope as 0. We do not consider that case. We start for only distinct elements. We start from here. Okay. So for this, what will be the slope? So one single point will never form a line. Okay. What will be the slope in this case? 1. Okay. And we increment the frequency to 1. Okay. For the next case, what will be the slope? 2 minus 1 upon 5 minus 1. Okay. In this case also, sorry, instead of storing the slope as an integer, we store the slope as a pair. Okay. So the slope in this case will be 1, 1. The slope in this case will be 1, 4. Okay. And the slope in this case will be 4, 4. Okay. So in this case, the maximum frequency that we got was 1. Okay. So what does this mean? This means that the first element 1, 1 is here. 2, 2, is here. Okay. 5, 2 will somewhere be here, and 5, 5 will somewhere be here. Okay. This 4, 4 we store as after taking the GCD. Okay. So in this case, if we store this 4, 4 as 4, 4, okay, we get this as a different pair. Okay. And this answer that we get is 1. Okay. So the overall answer should be 1 plus 1, that is 2. But will that be the correct answer to our solution? No, right? So what we have to do, we have to store after calculating the GCD. Okay. So the greatest common denominator in this case. So in this case where the points were 1, 1 and 5, 5, the pair of m was 4, 4. The greatest common denominator was 4 itself. If we divide this by 4, we get as 1, 1. We already have a 1, 1 present in the map. So we increment the frequency by 1. Okay. So the frequency we get is 2. So the overall, the maximum number of elements lying on a line of which this P will be a part of, that is 1, 1 will be a part of, is equal to 3. How? This will be the line 1, 1, 2, 2 and 5, 5. Is this clear now, Chirag? Okay. Similarly, we proceed for other elements also. So then let's say we take up the other element, this. Okay. We'll try to calculate the slope with all of them. Okay. So these will be the 3 lines possible. And in this case, for each element, we will only get the answer as 1, 1, 1. So the overall answer will be 2. So in the end, we'll get the maximum as 3. Is this solution clear, or do you want me to do the dry run for the next case as well? Yes, we are erasing the map. So why we are erasing the map? Why we are erasing the map? Once we have this, okay. So with this element present, okay, with this element present, okay, we have this line, okay, we have this line possible with the maximum number of elements as a part of it. Okay, now we are calculating for the next line. Okay, so for the next line, the slopes will all be different, right? The slopes will all be different, right? So we'll be calculating with respect to this element. Okay, so do we need this data again? We do not need this data again. So for what we are trying to take advantage of is that for each element P1, the calculation of M will be different. Okay, and in that case, the map of P1 is not beneficial in case of P2. Okay, that's why we clear this map, and in the next iteration, we again start from scratch. Okay, and that's how we get the time complexity to be space complexity to be order of n. Is this clear now, Chirag? Okay, cool. Anyone else has any other doubt? If no, please click on no. If no one else has any other doubt, please. Okay, guys. Okay, so I'll stop the class here. Okay, probably not tomorrow because I'll have to discuss with Kshitij or Tarun first. Okay, so if not tomorrow, like on Wednesday probably. Okay, like I also don't have the schedule. So if you will have a class tomorrow, you will be informed by. I'll try to get that information to you by 12 or 1. Okay, latest. Okay, so if you will have an extra class tomorrow, you'll get the information by 12 or 1 through your groups tomorrow. Okay, and if not, we'll schedule the extra class whenever it's possible, earliest. Okay, and in that, the only topic left for discussion is the Rabin-Karp string matching algorithm. Okay, for which the problem statement I have already defined. So this is the problem statement for the Rabin-Karp string matching algorithm. Try to think of how you will solve this problem. Okay, and we'll discuss this in the next class, in the extra class. Okay. Good night, everyone. Okay, hope you had a great, not great if a good class. Okay, so it was a little slow because the 2D point explanation took a little more time. Okay, the next topics and schedule whenever will be informed will be updated on the dashboard only. Okay, so good night, everyone. Have a great night. Okay. And tomorrow is a holiday, so probably tomorrow won't be the extra class. Okay. If tomorrow will be the extra class, you'll get the information by 12 or 1. Okay. Good night, everyone. Good night.